Hi guys, so in this video we're going to discuss what intermolecular forces is. So we're going to explore its types from ion-ion interaction to ion-dipole interaction to dipole-dipole interaction, including hydrogen bonding and to London dispersion forces. So we have this ion-ion interaction, and we know what an ion is. It is basically the atom or a group of atoms that carries a positive or a negative charge, resulting to the losing or gaining of electrons. Just like for example, we have the atom sodium that carries a positive charge and a chlorine that carries a negative charge. And we know that the two opposite charges attract each other by a force because these two charges are being pulled by a force called electrostatic force. And this force is directly proportional to its charge and inversely related to the distance between them. So now we have this sodium ion that carries a positive charge and chlorine ion that carries a negative charge. So we know that they both pull each other because they are opposite, they attract each other, and the interaction that occurs between these two ions is what we call the ion-ion interaction. It is an interaction between two ions. So let's consider some example like the potassium that carries a positive charge and the chlorine again that carries the negative charge. So again, these two has the opposite charges, so they pull, they attract each other. So we have the interaction ion-ion interaction between these two ions. So that is what an ion-ion interaction is. It is an interaction between two ions. So let's proceed to ion-dipole interaction, and we know what an ion is, so we're going to tackle about what the dipole is. Dipole, di means two, so it is a substance that contains two charges, a positive and a negative. So the good example for this is a carbon monoxide, and we know that oxygen is more electronegative than carbon, so it will pull more electrons towards itself. So it will carry a negative partial charge, while in carbon it will carry a positive partial charge. So this is what considered a dipole because it contains a positive and a negative charge, and it is also considered a polar. So let's consider some example like we have chlorine, an ion, and a water molecule, and we know that the oxygen here will carry a partial negative charge, while the hydrogen and a water molecule will carry a positive partial charge. So this chlorine and ion here will be attracted to the partial positive charge of hydrogen, and the interaction that happens here is what we call an ion-dipole interaction. So next we have the dipole-dipole interaction. So as you can guess, it is an interaction between two dipole molecules or polar molecules. So again, we have the example of carbon monoxide, two carbon monoxide molecule. So we said earlier that oxygen is more electronegative than carbon, so this oxygen will bear a negative partial charge, while carbon will bear a positive partial charge. So again, by using the electrostatic force, this partial negative charge of oxygen will be attracted to the partial positive charge of carbon, and the interaction that occurs between these two dipole molecules is what we call the dipole-dipole interaction. So let's consider some example. Again, we have two hydrogen chloride, and chlorine is more electronegative than hydrogen, so it will bear a negative partial charge, while hydrogen will bear a partial positive charge. So again, this negative partial charge of chlorine will be attracted to the positive partial charge of hydrogen, and the interaction that occurs there is what we call a dipole-dipole interaction between these two dipole molecules, the hydrogen chloride. We have the specialized type of dipole-dipole interaction. We have the hydrogen bonding. This occurs when the hydrogen bonds with the most electronegative elements. We have the nitrogen, oxygen, and fluorine, or simply the NOF. Now, when this hydrogen bonds with this one of these most electronegative elements, they produce a more polar bonds, means more greater dipole interactions, therefore greater dipole-dipole interactions. So let's see the example of two water molecules. And now keep in mind that the bond within this one molecule of water is called a covalent bond, and we have two types of covalent bond. We have the nonpolar covalent bond, in which the electrons are shared equally, while in polar covalent bond the electrons are shared unequally. So we said that oxygen is more electronegative, so it will bear a negative partial charge because it will pour more electrons towards itself. Thus, hydrogen bears a positive partial charge, and this positive partial charge of hydrogen here will be attracted to the partial negative charge of the oxygen to the another water molecule, and the interaction that occurs in these two water molecules, between these two water molecules, is what we call hydrogen bonding. And this is an example of intermolecular force. Inter means between two, the force that exists between two molecules. So we said earlier that this is the bond in one molecule of water is called covalent bond, and that it is an example of intramolecular force. Intra means within or inside, so that's the difference between intermolecular force and intramolecular force. Intra means within one molecule, while inter is between two or more molecules. So that is hydrogen bonding, when hydrogen bonds with the nitrogen, oxygen, or fluorine, or simply the NOF. So let's proceed to the last type of intermolecular forces. We have the London dispersion force, or also called as the van der Waals force. So this is the weakest of all intermolecular forces. They are found in everything. In any molecule or ion, they have this London dispersion force, and that they are more significant in nonpolar molecules. So let's say, let's have an example. We have this helium atom here. Let's say this is its nucleus. So I'm gonna draw its entire atom. So let's say for example, we have 8 electrons inside this helium atom. So we can see that the electrons are distributed equally in this helium atom, so it is non-polar. So at some point time, sometimes this electron cloud gets distorted, and when that happens, we can have a deficiency of electrons, like we have more electrons to the one side as opposed to the other side. So when that happens, we have this negative on this side and a positive on this side, so we can develop a dipole, a temporary or momentary dipole that lasts a very short time at this point. So what happens when so let's see what happens when another helium atom is interacted with this helium atom. So when that happens, the electrons of this side will drift to the left side of this, because we have less electrons at this side. So when that happens, when the electrons move to the left side, we have a negative on the left side, while positive on the other side. So the interaction that occurs between these two, the positive and the negative, is what we call the London dispersion force. This is a very, very weak interaction, in that it is very fleeting. It is the London dispersion force here is more weaker than any of dipole-dipole interaction. So So let's rank the strengths of intermolecular forces from the strongest to the weakest that we have tackled about. Now first, we have the ion-ion interaction, which is between formal charged particles. Then next, we have ion dipole interactions, which is between a formal and a partial charged particles. Then we have hydrogen bonding, which is a very powerful type of dipole-dipole interactions. And next we have the normal dipole-dipole interactions, which is typically between polar molecules. Then lastly we have the weakest, which is the London dispersion force, or the LDF. So that's it for the lesson today, and I hope you learned something, and thank you for watching.